In fact, let's just do this. We'll fit it to height, x plus 2, x squared plus x plus 2. So I squared it, I added 2, and I subtracted 2. Good. That gave me 4. And then I put the 4 in, x plus 2. We're all good. So now we're asked, are f and g inverses of each other? Well, we want to compose them to find out if it equals x. So does f of g equal x? Let's look at this, and I'm going to compose them here. Actually, we already did compose them in number 6, didn't we? So the answer is no. See number 6. Okay, well that's the first page. Moving on now to the second page, which I think it gets a little shorter here as we go. Let's get this back out so we can see these problems. We're going to answer each of the following completely. Show all work, all fractions must be simplified and combined. At noon, Al is 6 kilometers north of point 0, traveling north at 4 kilometers per hour. Also at noon, Barb is 4 kilometers west of O. So I want to put my north-south line here. Let's give myself a western line here. Okay, remember north, never eat shredded wheat. You ever hear that one before? It's good stuff there, guys. Good stuff. All right, at noon, Al is 6 kilometers north. So he's up here at 6. And he's traveling north. He's going further away. He really wants to get away from point O. He is going 4 kilometers an hour. He is just cruising. Also at noon, that's important, it's at the exact same time, Barb is 4 kilometers west. And she's traveling east. She's heading back towards O. Maybe that is why Al is trying to get away from O. Perhaps Al and Barb do not like each other. So, what's happening here is these guys are moving. Okay, Al is heading up and Barb is moving in. Okay, so our triangle, all right, we're trying to find the distance between these two guys, these two people, at any time. So our triangle is going to look like this. And Al is 6 plus 4 kilometers every hour. That's 6 plus 4 times the time. Now Barb is 4, but she's getting closer. She's getting 10 kilometers an hour closer every time. So those are our two sides of our right triangle. We know it's a right triangle because we're talking about the directions, north, east, south, and west. So my distance as a function of time, distance squared equals leg squared plus other leg squared. So my distance is going to be the positive square root of that. I don't care about the negative piece because we're talking about distance. That's positive and only positive. So 4 minus 10t squared plus 6 plus 4t squared. And sure, you could distribute and combine like terms, but you know what? When I'm plugging in t twice. That's pretty easy already. That is simplified. Okay, so my time at which the distance is a minimum, I'll need my calculator for that one. Okay, but while we're waiting for the calculator to load, let's look at things like our x and y values, our domain and our range. My domain here, time for anything to happen has to begin, but we could be at no time. We can find their distance when time has not changed, so we will include 0. And we'll go up to, now if we think about this, we're just getting a rough estimate for the domain for our x and y, for our x min and x max. So the time they're going to be the closest to each other is possibly going to be the straight line distance. That's certainly a possibility. The point is, when they get past this point right here, when Barb gets to the eastern side, she's going to be further away because Al is still going to be continuing up. So this straight line is going to be shorter than this diagonal line. So I just need to find out how long it takes Barb to get to point O. And if she's 4 kilometers away and traveling 10 kilometers every hour, okay, her distance is equal to her rate times time, which means her time is 4 over 10, or 2/5. So I am not going to go any bigger than that on my x min and x max. So here's our calculator. We don't need all that stuff in there. I need an equation. So let's go to my equation here. Let's clear that out. And my equation was the square root of 4 minus 10t squared plus 6 plus 4t. And of course I'm using x's instead of t's, and that again is squared there. All that's underneath the square root. My window, I'm looking at 0, we said, and 2/5 is 0.4. 2/5 is 0.4. And my scale, that's small enough, I'm just going to go by zeros. Now this is interesting, my y-min, we're talking about distance here. Minimum distance obviously is 0. Now the maximum distance, I have no idea, but remember what we did. We plug in 1/5. We plug in 1/5 for that. So I'm going to go to my second window, make sure I'm set up on the ask feature. Now I'm going to go into my table, and I'm going to put in 1/5. And it's going to give me 7. So I'm going to go back to my window, and I want to give myself some wiggle room. Instead of going just to that 7, I'm going to go up to 10. Maybe even 15. Let's do 15. And we'll graph it and see what it looks like here. So there's our graph, and you can kind of see it's a little parabolic there. This is getting lower, and then it's getting higher again. That really is not a nice picture, but it's a nice picture for what we want. Second trace calc, I'm going to a minimum. I need my left bound, so I need to go to the left here. So I'm going to go to that bar that jumps up a little bit. And right there, I'm going to hit enter. And now I'm going to scroll all the way over and probably to the other bar that jumps up over there. Okay, that's plenty far enough. We can see the values of y are increasing. Enter. And now I can make my guess somewhere in between here. Enter. And there we go. There's our minimum distance that occurs at 0.13793,103 hours. So I'm going to drop this right in here. It's a little bigger than I need, so let's make this a little smaller. And remember that our x value is our time. Now, 0.137, like, hey mom, I'll be back in 0.137 hours. No, that doesn't work. So what we need to do is find out what is 0.1379 hours. Well, I did not get a decimal in there. Let's try it again. 0.1379. Now we're talking hours here. So in order to convert that decimal into hours, think about what we need to do here. Okay, I'm going to multiply this by 60, and that tells me it's 8.274 minutes. Okay, so that is roughly 8 minutes. So approximately 8 minutes. Interesting problem there. All right, let's look at number 14 here. A box with a square base and a top has a volume of 7 cubic meters. The material for the base costs $7 per square meter, and the sides cost $9. So I know we have a box. And notice this one, unlike the previous one we've done, this does have a top. So that means, oh my, this drawing is not the best. You know what? I want to start over. That means, since it has a top also, we have the 4 sides and a top and a bottom. So we have 6 pieces to our surface area. And this box is already looking better. Ding, 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 ding. Beautiful. Perfection right there. All right. So we have a box, and again, square base, so x, and this is some unknown height. We know the volume in terms of x and h is x squared h. Okay, and we know that the surface area is 2x squared, right? The top and the bottom, plus 4xh is the 4 sides. All right, now the box has a volume of 7 cubic meters, so this is equal to 7 cubic meters. We want to express the cost of the materials used to make the box as a function of the width of the base. Okay, well, the cost of the box in terms of x, well, the bases, the top and the bottom, cost $7. The material for the base costs $7 per square meter. The material for the sides costs $9. We can assume the material for the base and the top. For the base and the top costs that much. So $7 for the top and the base, plus $9 for the four sides. Well, unfortunately, this is not in terms of x just yet. Okay, I need to find a way to get rid of that h right here. Okay, and yes, I could just erase it and boom, it's gone, but that's not quite what they mean here. So I need to take this equation right here and find out what h is. Well, that's pretty easy. I'm just going to divide both sides by x squared and plug it in. So now I have my equation for the cost of the box in terms of just x. And I'm going to simplify that a little bit. There's 14x squared. This is 36, and 36 times 7 is 252 over x, because one x will cancel out with the other. All right, now we want to find the minimum cost of making this box. So again, we go to our calculator. We go to our y equals 14x squared plus 252 divided by x. And the window, again, you can't have 0 for your side lengths. Talking about, what else do we have here? The x max here, well, if the volume is 7, you know, we could have like a 2 by 2 by 2, which would be 8. So that would be a pretty good estimate for the maximum volume. This is not something that you necessarily want to go ahead and find the zeros of. It's not the cleanest problem to do. So you're going to have to kind of use a little bit of intuition on this one as opposed to the algebra. The algebra will fail you a little bit in this case. Volume again is 0, and you know what? If I'm doing 0 to 2, I can ballpark 1 for my y value. So, I'm sorry, for my x value in order to find my y value. So I'll plug a 1 in here, I get 14 plus 252. Well, that's 266. So I'm going to round that up, remember? So let's go like 350 and see what that does for me. This could be way off, or it could just be perfect. And there we go. And you know what? Our height and stuff was great. Our issue was our y values and our x values, our x max. So we mentioned 2 by 2 by 2. That does give us a volume of 8, which is greater than this. But we ignored the fact that it could have been a 4 by 4 by 1/2. Right? That also would give us an 8, which is about the volume here. So I need to go and change my window. It appears that a 4 is going to be more reasonable. There's my minimum value. We will locate that. Left bound. Perfect. Enter. Right bound. Fantastic. Enter. And I'm going to make an incredible guess. There it is. And there's my answer. So find the minimum cost of making this box. So this is the x value, which is the dimensions of my base. And this is my cost. 100 cost when x is 2.08 is $181.72. That is one heck of a box. On to